I'm Anju, Assistant Professor, Department of Information Technology from KCT College of Technology. So today we are going to discuss about the course Cryptography and Network Security. So we have framed 6 course outcome for this particular course. So already we discussed we covered 2 course outcomes. Then this topic comes under the third course outcomes. That is, it describes the principal knowledge of public key crypto system and key management. So the topic is public key crypto system. Before going to the in-depth session, we should have an idea about what do you mean by crypto system. This is a technology used to encrypt the original message into that encrypted format. So that technology is known as crypto system. So we are using, in that main ingredient is key values. So with the support of key values, we are doing the encryption and decryption process. So this can be classified into 2 sets. One is single key encryption and other one is 2 key encryption. The single key encryption, from the word itself we can identify only one key is used for both encryption and decryption. And it is otherwise termed as symmetric key encryption or one key encryption. So many names for this particular technique. And other method is public key encryption. Here we are using 2 different keys. One key is used for encryption and other key is used for decryption. The key which has been shared to everyone is termed as public, and the key which should be kept secret is considered as private. So with the support of 2 keys, we are doing the encryption process and decryption process. In public key crypto system, the most widely used algorithm is RSA algorithm. In modern computers, we are using RSA algorithm as the basic concept. So this algorithm was developed by 3 persons, Rivers, Shamir, Adelman. So based upon their first letter, they created the algorithm name as RSA. RSA. So this algorithm provides confidentiality, integrity, then authentication for our data. So let's see how the algorithm is framed, and with an example I will give a detailed description about RSA algorithm. So now we are going to discuss about RSA algorithm. So RSA algorithm consists of mainly 5 steps. So first, I have already told you RSA algorithm is full and fully related to the prime number generation. Not prime number generation, prime number is based on prime number calculation. So first we have to choose 2 different prime numbers. So we can given it as P and Q. Then we have to calculate the modulus of n value. N is equal to, the equation is P into Q. That is, we are multiplying the both prime numbers. Next we have to calculate the torsion function. It will be represented as phi of n with the equation P minus 1 into Q minus 1. Then next we have to select a random integer E. There is 2 conditions we have to satisfy in order to calculate the E value. The first condition, E should be in between 1 and phi of n. So phi of n we already calculated, that is torsion function. Then one more condition is left, the GCD of E and phi of n should be 1. So based upon these 2 conditions, we are calculating the E value. Here in RSA algorithm, E should be considered as the public key. Next step, we are going to calculate an integer D. So here the D value will be considered as the private key. So how to calculate D value? Now there is we are using congruence concept. Okay. So the congruence concept comes under number theory concept. So what is the concept behind here? There is a congruence algorithm. E into D is congruent to 1 plus mod phi of n. So based upon this congruence equation, we can solve this particular value, D value, as D equal to 1 plus k into phi of n divided by E. So this all this calculation I will explain with an example. Next, finally we move to the encryption step. So let's consider M is our message. In order to encrypt the M value, we are doing encryption equation. So here C will be considered as the ciphertext. So C is equal to M power E mod n. So E already we calculated here based up in the 4th step. And for decryption, in order to get our original message, that technique is called decryption. So how to decrypt the message with the support of this particular equation? M is equal to C power D mod n. So we discussed RSA algorithm, right? Now we are going to discuss the algorithm with an example. So first I told you, you have to select 2 prime numbers. So here I selected 2 prime numbers, P is equal to 3 and Q is equal to 5. Next we have to calculate the modulus value, that is n. How to calculate modulus value? Multiply these 2 prime numbers. So you will get 15. Next Next, you have to calculate the torsion function phi of n. The equation is p minus 1 into q minus 1. So you will get 2 and 4. 2 into 4, you will get 8. Then E is our public key. So it is a random selection. So how we are selecting the public key with the two conditions? E should be less than, E should be in between 1 and phi of n value, that is our torsion value. Then one more condition is left, GCD of E and phi of n should be 1. So I selected E value as 7, it satisfied the both two conditions. So E will be considered as our public key. Next we have to calculate our private key D. So for this we can use two different methods. First method is congruent with the support of congruent equation. So I have during the explanation of RSA algorithm, I have told you how this equation we have derived. One more method is there, extended Euclidean algorithm. That is also we will discuss later. Then, so with the support of all this value, we are going to calculate D value. So here we are giving the values for key starts from 0. So we are randomly putting values for k. Whenever you will get an integer value, that moment you can stop the iteration. Then you can take the value as D. So first you have to calculate. You have to give the k value as 0. So the first equation will be 1 plus 0 into phi of n. Your phi of n value is 8. Then 8 by 7, you will get 1 by 7. So here you will get a fraction value. So don't take that particular iteration. Next iteration, put k value as 1. So again it will be 1 plus 1 into 8. Then you will get 9 by 7. So here also you will get a fraction. Now change the value of k. Put k is equal to 2. So 2 into 8, you will get 16 plus 1, 17. 17 by 7 is not satisfied. Then k becomes 3. 25 by 7. This is also not satisfying. Next, k becomes 4. So you will get 33 by 7. Not satisfying. Then k becomes 5. So 8 into 5, 40. So 41 by 7. This is also not satisfying. So we can extend this. We can give k value up to what? The range become up to the k value should be less than E. So up to this we can give k value. So next value I am giving it as k is equal to 6. Now 6 into 8 you will get 48. 48 plus 1, 49. So 49 by 7 you will get 7. So now we reach an integer value. So now we can stop the iteration. So you will get k value as D value as 49 by 7. So after finishing your algorithm, now you have the public key and private key. Now we are going to the encryption and decryption procedure. So let's consider our message as 2. So the encryption equation I have already told you. So here we are for ciphertext we are using the character C. So C is equal to m power E mod n. So here we are simply putting the values. M I randomly put the value as 2. So 2 power 7. 7 is our public key 7. Then mod n value we already calculated 50. So it will become 128 mod 15 you will get. So after finishing, the mod operator is nothing but you are calculating the remainder value. After finishing your calculation you will get 8 as value. So this is your ciphertext. Now so all this operation will be done by the sender side. Now we transmitted our data and the receiver is received the data successfully. After receiving the data, the receiver should decrypt the ciphertext. So what is the decryption equation? So we are going to calculate the m value. The equation is C power D mod n. So we are applying all these values in your equation. Then you will get ciphertext equal to 8. So 8 power D value is 7. So 8 power 7 mod 50. So after doing the calculation you will get this number. Then we are doing the mod operation. So after finishing mod operation you will get this value. Then you are doing mod operation. Finally you will get the number as 2. So this number is equal to our actual message. Right? I hope you understand the RSA algorithm by this example. So the course outcome for this particular RSA algorithm, so I have already told you we have 6 course outcome. So the RSA algorithm, the course outcome for this RSA algorithm is, it describes the principles of public key crypto system and the key management concept.